Hello, my name is Imad About and I'm professor at Aix-Marseille University, and today guys I'm going to talk to you about biodentine interaction with the target tissues and how it can decrease pain and leads to pulp tissue regeneration. So as you all know, among the numerous applications with biodentine is that can be directly applied onto the pulp or indirectly, which is called indirect pulp capping. And in both situations, as you all know, the major factor for the success of this treatment is to eliminate bacteria. If you eliminate bacteria, you are successful. If you do not eliminate bacteria, you will get an inflammation, and with inflammation you will get pain. And this is why the patient will come to complain to you in your private practice. So you understand also that the choice of the material is very important, because the material should not allow the penetration of bacteria into the pulp. Otherwise, again, you will get the inflammation and no regeneration. And with biodentine, which has been evaluated on different bacterial species, it has been shown that this material has a bacterial growth inhibitory effect. This has been demonstrated on this slide, as you can see on different strains, and the highest growth inhibition zone was obtained with biodentine as compared to MTA or glass ionomer cement. So this is one of the important factors, but in any way, if the choice of the material is not the right one and you get a bacterial infiltration, then you go to some inflammation of the pulp and the people will complain, the patients will complain of pain. And this is one of the major problems. The question is, can we investigate the pain feeling in vitro? This was a major influence and a major factor that we needed to study. And one of the things that came to us quite often from practitioners is to say that our patients come with an amalgam restoration or resin composite restoration. When they come, we remove it because the patients complain of pain. We put biodentine and the pain just disappears. So we wondered if when we apply biodentine, if this biodentine can decrease the pain sensation of the patients. So what you see here, odontoblasts have a process which goes deep into the dentin. And these odontoblasts act as sensor cells. Why do they act as sensor cells? Because they express what we call transient receptor potential channels. These channels act as pain sensors because with these receptors, the odontoblast feels noxious cold, and with some other receptors they can feel noxious heat, mechanical stimulation, and chemical stimulation as well, for example, to toxic compounds. So this odontoblast express the receptor as you see here, but the expression of this receptor is low. This is exactly what you see on this slide, on the second slide, which is in red. The third slide is just in blue, just to show you this is a control. Then when you look at the same type of tooth when it is inflamed, this is a carious tooth. What you see is the injury side. This is what you see here. And then when you look down on this part, you will see that this is the same slide with another staining. And then when you look at the expression of this receptor, you notice that in carious injuries, it increases. The increase is very high, and this increase that you see here is more intense than in the healthy teeth. And the surprise was that when you look at the expression of this protein, it's not only under the carious injury, but also it is elsewhere in the other areas in the pulp, which means that the odontoblast in the old pulp express a higher level of this protein, indicating that there is a high stimulation. This stimulation indicates that these cells will release mediators of inflammation that will affect the nerve terminals, and this is why the patient feels pain. So can we reproduce this in vitro? The answer is yes. So this is what we did. We take fibroblasts, we apply a pro-inflammatory factor, which is called TNF-alpha, and as you can notice here, there's a dose-response effect. When you add more of this factor, you have a higher increase of this receptor. And surprisingly, when you look at the second histogram, you notice that this is the control. Then when you apply biodentine, there is no increase of the expression or decrease, but when you look at the incubation with TNF-alpha, that is the pro-inflammatory factor, you notice that there is a high increase, indicating that the cells are subject to inflammation. When you add the extract of biodentine on the inflamed cells, you notice that there is a significant decrease of this receptor. This means one thing which is very clear: when we apply biodentine on inflamed cells, there is a decrease in the expression of this receptor. Then we wonder what will happen on the functional activity. So what you see here is a laboratory protocol with which we can stimulate the cells with a cinnamaldehyde. It's a chemical that stimulates this type of receptor, and you notice that the increase is very low. But when you add the pro-inflammatory factor, the entrance of calcium ions increases in a very significant way. This is what you see with the TNF-alpha on the second trace. And when we add biodentine and the pro-inflammatory TNF-alpha, we notice that there is a suppression of this response, and this is what you see on the histogram with the evaluation, with the quantitative evaluation. What does this mean? This means that biodentine decreases the expression of the pain receptors during the inflammation, but it also inhibits its functional activity. And this might explain why, when the patient leaves after applying biodentine as restorative materials, we usually don't have a feedback of pain in these patients. So we have seen what biodentine does when it is applied for indirect pulp capping. Now let's see what happens when we apply biodentine in direct pulp capping. So this is what you can see on this slide, where biodentine was applied directly onto the pulp in human teeth, and the evaluation was done 6 weeks later. What you see here is that biodentine, the same way as MTA, induces dentin bridge formation. We wanted to understand how does this dentin bridge formation is made. So we simulated this situation in vitro. We incubated the biodentine with a culture medium, applied it on pulp fibroblasts. We made injuries on the pulp fibroblasts as if we are making injuries to the pulp. Then we applied biodentine on these injured cells and measured the growth factor synthesis. What we found is that angiogenic growth factors are sensitized and produced, and angiogenesis is essential for the regenerative process. Then we measured an important factor which is called TGF-beta1, and whatever the surface of the material used, we noticed a significant increase of TGF-beta1. This has a significant importance in the pulp because this factor is involved in the differentiation of odontoblasts, which means rendering these cells able to produce the reparative dentin. And we included this factor into polymers in order to understand what other roles it might play. And this is what you see here. We applied, we incubated the cells on a soft matrix as if they are incubated onto the pulp. Then we placed TGF-beta1 containing particles on one side, or other factors, or even empty particles without any factor. And what you see here is the appearance of cells directly after culture, after 6 hours of culture. The cells start to spread. This is what you see after 3 days, and after 3 days you see this reference point there. Please watch it and look at the cells that you see here and see how the cells will migrate and which is the direction of this migration in function of time, of course. So this is what happens. Cells migrate towards the reference point, then they will exceed it, and then will go far beyond. The final result of this migration is the following, that cells leave from this start point in the middle and they migrate towards TGF-beta1. This means that TGF-beta1, which is produced after the application of biodentine, guides the migration of stem cells towards the biodentine application site. And since we can apply this material at any surface area, it means that we can apply it also for pulpotomy. And this is what has been shown recently. In pulpotomy, Biodentine was applied in primary teeth, and what you see is that the success rate of this application is very high. It's even higher than in DA, but the difference is not statistically significant. So in addition to this study on pulpotomy that I've just presented you, several papers have appeared on pulpotomy on the same subject, but in addition to this application, since the release of Biodentine late 2010, several applications and clinical trials have been published on the various applications of Biodentine. There is a complete list that you can find on its application in the crown. These include clinical trials as well as clinical cases. They are listed here on this table, and you can also find the clinical applications and the published ones in the root, and there is a complete list in this table as well. And the whole story I just told you, you can find it written in a review in the Italian Journal of Endodontics. This will be published in 2016. I think it will appear in November. So the conclusions of this presentation is that Biodentine, as you have noticed, is a biocompatible and bioactive material. It decreases the expression of pain receptors and inhibits their functional activity. This is why patients do not feel pain when Biodentine is applied in indirect cavities. This material can be applied safely onto the pulp, whatever the cavity size. This explains why it can be used even in pulpotomy. Its application directly onto the pulp induces mineralization and dentin bridge formation. And this formation implies that there is no inflammation, because inflammation precedes regeneration. And this regeneration seems to be due to the increasing of the secretion of TGF-beta1, which attracts stem cells to Biodentine application site, and these cells will synthesize and regenerate the missing dentin. Thank you guys for listening to me. It was a great time. Thank you very much.